Unit 6, Lesson 2, Transformations of Sinusoidal Functions. So recall from our last lesson that we now know how to graph the graph of sin x and cos x using key points. So anytime you're asked to graph sin x or cos x, these are the only points that you need to know. Okay, I know the table of values in our last lesson had a bunch of points, but remember you only need a few points in order to see the trends in the shape of the graph. Okay, so these are the important ones to plot. Okay, so there is one cycle of the sine function. So the maximum value is y is equal to 1. The minimum value is y is equal to negative 1. The period is 360 degrees. The axis is at 0. And the amplitude is 1. So that's all review from the last lesson. Okay, let's look at the cosine function and graph it. Okay, so there is the graph of the cosine function. Its maximum value is at y equals 1. Its minimum value is at y equals negative 1. Its period is 360 degrees. Its axis is at y equals 0. And its amplitude is also 1. So these are what we call the base graphs of the sine and cosine function. Okay, so in today's lesson, we're going to learn how to apply transformations to these graphs. So anytime you're applying transformations, you always want to start by plotting the base graph, so these two graphs. Then you would start applying your transformations one by one. Okay, so let's work through some examples to explain that. Okay, so a review of transformations. Remember that A vertically stretches or compresses the function. And to apply that to a graph, you're going to multiply all the y values of the base graph by the value of A. Okay, remember K is a horizontal stretch or compression. And to apply that to a base graph, you're going to either multiply the x values by 1 over K or divide the x values by k. So it's the same thing. Okay, and then your P is your horizontal translation and your Q is your vertical translation. Okay, so let's try example 1. Graph f at theta equals 2 sine theta. So here we have an A value of 2. So that means this graph is going to be vertically stretched by a factor of 2. So to apply transformations, step 1 is always graph your base graph. Okay, so let's create a table of values with our base graph. Okay, and our base graph is just made up of those key points that we saw at the start of the lesson, and those key points are from our base graph. So if you forget them, you can grab them from up here. Okay, so let's plot that base graph on the graph to the right. Okay, so there is our base graph. Now we're going to apply our transformations. So to apply a vertical stretch of 2, we're going to multiply all the y values from our base graph by 2. Okay, so our values of theta are still all the same. But now I'm going to take all the values of f at theta and multiply them by 2. So 0 times 2 is 0, 1 times 2 is 2, 0 times 2 is 0, negative 1 times 2 is negative 2, and 0 times 2 is 0. Okay, let's go ahead and plot this graph now. Okay, so there is our graph of f at theta. So you can see that the original graph, the base graph that I've drawn in black, has been vertically stretched by a factor of 2, and that resulted in that pink graph. Okay, let's state the domain and range. So you're always stating your domain and range of the final transformed graph. So in this case, it's our pink graph. So our domain here is x is an element of the real numbers such that x is greater or equal to 0, but less than or equal to 360. And again, keep in mind that these functions repeat themselves, but we are only dealing with the points from our table, so we do have restrictions in place. Okay, same with the range. We have y is an element of the real numbers such that y is greater or equal to negative 2, but less than or equal to positive 2. Okay, and just as a little extra, keep in mind, you should be comfortable stating the period, amplitude, and equation of the axis, right? So the period would be 360 in this case. The amplitude would be 2, and the equation of the axis is y equals 0. Okay, so that could be a question that I ask on the test as well. Okay, so graph g at x, which is equal to sine 2x. So in this question, we have a k value of 2. So that means we're going to have a horizontal compression. Okay, so let's go ahead and always start by graphing our base graph of sine. So remember again, your base graph is made up of those key points from above. Okay, so let's plot that on our graph. Okay, now let's apply our transformation. So a k value of 2 means that I'm going to take all the x values and divide them by 2. Or think multiply by 1 over k, it's the same thing. Okay, so my g at x column is still all the same. But now I'm going to take each of my x values and divide them by 2. Okay, let's go ahead and plot those points. Okay, and you can see that the graph now has been compressed. Okay, so let's state our domain and range. And remember, we state the domain and range of our fully transformed graph, so that pink graph. So our domain is going to be x is an element of the real numbers such that x is greater, such that x is between the values of 0 and 180 degrees. And the range is y is an element of the real numbers such that y is greater or equal to negative 1, but less than or equal to positive 1. And again, be comfortable stating the period, amplitude, and equation of the axis. So the period here would be only 180 degrees. The amplitude here would be 1. And the equation of the axis here would be y equals 0. Okay, example 3. Graph h at x equals negative 3 cos 1/2 x. So we have 3 transformations here. Okay, we have a vertical stretch of 3. because our A value is 3. We also have a reflection on the x-axis because our A value is negative. And we can apply those at the same time. Okay, instead of applying just our A value by multiplying our y values by 3, we could actually multiply our y values by negative 3 to do both those transformations at the same time. Then we also have a horizontal stretch by a factor of 2 because our k value is a half. Okay, so as always, let's start with our base graph. So this time we need our base graph of cos. So if you forget it, look at the key points that we wrote down at the very start of the lesson. Okay, so there are the key points of our base graph. So go ahead and plot those on the graph because you always want to start by graphing your base graph. Okay, so we'll label it because we're going to have more than one graph on this grid. Okay, now let's apply our transformations. So we need to multiply all of our values of h at x by negative 3. Okay, because that's how you apply your A value. Right, your A value, you multiply all your y values by the A value. And I said earlier that we could include that reflection by multiplying all our values not only by 3, but by negative 3, and that will automatically apply the vertical stretch and the reflection at the same time. Okay, so let's go ahead and do that. So 1 times negative 3 is negative 3. 0 times negative 3 is 0. Negative 1 times negative 3 is positive 3. 0 times negative 3 is 0. And 1 times negative 3 is negative 3. Okay, let's apply our final transformation. So the other transformation is we have a k value of a half. Okay, and to apply a k value, you always take the x values in your table of values from your base graph, and you divide the x values by the k value. So we would divide all our x values by a half. So that's our k value. But you know that dividing by a fraction is the same as multiplying by the reciprocal. So instead of saying, let's divide all of our x values by a half, it's the same as saying, let's multiply all of our x values by 2. Okay, so let's do that. So 0 times 2 is 0. 90 times 2 is 180. 180 times 2 is 360. 270 times 2 is 540. And 360 times 2 is 720. Okay, now that second table of values is the points of our transformed graph. So let's plot those. Okay, so there is our final transform graph. Now let's state the domain and range of that final transform graph, so that purple graph. So the domain is going to be equal to x is an element of the real numbers such that x is greater or equal to 0, but less than or equal to 720. And our range is going to be y is an element of the real numbers such that y is greater or equal to negative 3, but less than or equal to positive 3. Okay, and then as extra, let's state the period. Okay, the period here is 720. So that's the time that it takes to make one full cycle. Okay, the amplitude going to be 3 because that's the distance between the max or the min and the axis. And then the axis is at y equals 0.